Hello, everyone. We are Team Master Son and his friends, and our project focuses on transformer modeled Chinese poetry generation. First, let's describe our problem. Our goal is to use deep learning to generate classic Chinese poems. The reason why we choose Chinese poems because it's a very popular topic in natural language processing, and the classic Chinese poems are concise but informative. They are well structured, and they also recall special tonal pattern to form the rhyme. And the tonal pattern is basically known as 平仄. Uh, in the right panel of this slide, you can basically see a very classic Chinese poem. Every Chinese people knows this, and it follows. It is an example of the poem of the type that we choose. It's called 7-character 绝句. Um, uh, for the previous works, a lot of people used generation by templates. This is very ancient. It doesn't require neural network training. And also, a lot of people use the genetic algorithms. It involves a lot of mathematical computation and genetic algorithms from biology. And also, some people use static machine translation methods. Most recently, a lot of people have tried natural language processing in the deep learning field to generate Chinese poems. Those include RNN encoder, decoder, and transformer GPT-2 implementation. The transformer model is proposed in the famous paper Attention is All You Need by Google, and it is a model that uses attention to boost the speed with which this model can be trained. And the encoder decoder structure can be seen here. And there is a drawback of transformer model. It has limited context dependency, and it also suffers from context fragmentation. Then in order to resolve those problems, the Transformer XL is proposed. And it resolves those problems by introducing two unique additions. First is recurrent mechanism, and second is relative positional encoding. The dataset that we used for our project is selected from comprehensive database of Chinese poetry. And this is a link. Oh, sorry. This is a link to the dataset. After parsing, the dataset that we can use for our 7-character 绝句 poems consists of some 83,000 poems and 300,000 some lines and a lot of characters. And for the data pre-processing, we flattened the poems into one line, added start of sentence and end of sentence to it, and feed into the Transformer XL language model. The approach that we took is pretty self-explanatory. We first pre-process the poems, and we generate embedding dictionary in a way that is very similar to the homework. We just create a huge dictionary of characters to its precision, and we feed that into the Transformer XL model. Did some extensive training and after the training, we use random outputs as seed and feed it back to the model and generate AI poems. The reason why we do this is because our model has to take one line of poems to generate the following lines, and it is really hard for us to find any more poems, given that we have used some 83,000 poems for training. And this is our results. For the human evaluation part, we put up the website at this web address, and I can show you right here. And as you can see, a lot of people have tried to identify whether some poems are generated by AI or not. And the accuracy rate is about like a third. And we think we did a pretty okay job here. And in conclusion, we find that Transformer XL is a powerful model and could be used to generate well-formatted, meaningful poems in Chinese. Not all the results follow the desired constraints, but preliminary experiments have shown that it provides a good start for future improving the overall system. Also, we found that Transformer XL is very sensitive to hyperparameters. That's why we did hyperparameter tuning a lot. For future work, we would like to make the model learn more general structures and also generate more kind of text based on requirements, not only 7-character 绝句, but also like 5-character or even those poems from Song Dynasty. And we also would like to pre-train the language model and add some semantic encodings to let the model give more meaningful results. Thank you. That's it for our presentation.